Hi, this is a quick tutorial on how to calculate some inferential statistics once you've already got a scatter plot up and running. So if you don't know how to make a simple scatter plot, you should quickly flip back to the previous tutorial, and that should give you a good idea of what you'd need to do. So in this situation, we've already got a scatter plot, and as you can see, we've got hourly wages on the x-axis and life satisfaction survey scores on the y-axis. And as we can see visually, it looks like there is a positive relationship between these two variables. Something we might like to include in our graph, though, that would further help quantify this relationship would be a regression line. And there's a tool for making that in Excel. You'll find that in the chart layout option under the trend line heading. So we will click trend line. In this case, because we are exploring a linear trend line, that's exactly the option we're going to put, linear trend line. And as you can see, a linear trend line has been included for the data. So if we click on the linear trend line, right-click it, and then head to the Format Trend Line heading, there are a few other things we can do. So here we can select the kind of trend line we would like to use. In this case, again, we'd like it to be linear. Some other things we can do, we can get Excel to actually display the equation, so y equals mx plus b, for the regression line on the chart. And we can also get Excel to display the r-squared value on the chart. So for those of you who haven't taken introductory statistics yet, the r-squared value is just the amount of variance in one of these variables that can be accounted for by variance in the other variable. Call this the shared variance. So as you can see, y equals 0.5232x plus 35.06. So this does indicate that as x, our hourly wages, increase, predicted values for the y variable, this would be life satisfaction scores, also increase linearly. So I'm going to put our r-squared value, I'm just going to copy it out into this heading. Now, a different thing we might want to calculate on this data would be Pearson's correlation coefficient, also known as Pearson's R. And there's a formula for calculating this on Excel. So the formula itself is, I'll put equals. Oh dear. There we are. So we've got the correlation function, correl. As you can see, we need to include two different arrays. So each array just represents the different variable and the scores for each variable that we'd like to compare. So we'll let array 1 be the scores for the hourly wage data, and we'll let array 2 be the scores for the life satisfaction survey. And as you can see, we put that in, and Excel has calculated for us a Pearson's correlation coefficient just below 0.75, so this is a pretty strong correlation. Just a little fun fact, the r-squared value that is represented on the chart is simply the squared value of Pearson's correlation coefficient. So if you put equals the value in that cell to the power of 2, you will get a similar value. And this is a couple of different ways that you can help to quantify the relationship between two different variables on Microsoft Excel. So hopefully you found this helpful, and you can use some of these techniques in the graphs that you make for different psych labs throughout your undergraduate career. Cheers!